Good day, everyone. This is our Module 3 review. So in this review, we will discuss all the topics that we covered and discussed last time. Okay, so we will discuss Module 3.1 to Module 3.4. So we will discuss hypothesis testing of one parameter, hypothesis testing of two parameters. We will discuss the analysis of variance or ANOVA, and lastly, we will discuss the correlation and regression. Okay. So we will start with Module 3.1, or we will discuss the hypothesis testing of one parameter. Okay. So in terms of hypothesis testing, okay, so we have two types of hypothesis here. So we have the null hypothesis, or denoted as H sub 0, okay, and we have the alternative hypothesis, denoted as H sub 1. Okay, like I said last time, okay, so the distinct difference between the two is that in terms of hypothesis or null hypothesis, we are dealing with equality. Okay? Wherein the symbols that we use in terms of null hypothesis, okay, they have equal sign. Okay? So for example, we have here equal, we have here less than or equal, and here we have greater than or equal. On the other hand, we have the alternative hypothesis wherein, okay, if we are going or if we are dealing with equality in terms of null hypothesis, in terms of alternative hypothesis, we are dealing with the opposite. Okay? So in this case, we are dealing with inequality. Okay? Therefore, the symbols or operations that we use, okay, there are no presence of equality, no equal sign. So we have here not equal, greater than, or less than. So always remember, class, in terms of hypothesis and the types of hypothesis, okay, the null hypothesis, we are dealing with the equality. So there are equal symbols or signs. On the other hand, we talk about alternative hypothesis, we are dealing with certain inequality. So there are no equal signs. Okay? So please remember this. This is so important. No matter which hypothesis represents the claim, always begin the hypothesis test assuming that the null hypothesis is true. Okay? Because as we remember, okay, the one that we decide is the null hypothesis. Okay? So in terms of decision making in the last part of this problem solving, so we are going to decide whether to reject or fail to reject a certain null hypothesis. Okay, so always remember, always begin the hypothesis testing assuming that the null hypothesis is true. Because like I said, it is the one that we decide whether to reject or fail to reject. Okay? So let's review the steps on how we do a certain hypothesis testing. So number 1 is to specify the null hypothesis. Number 2, specify the alternative. So it is interchangeable. So it's up to you what you will specify first. But for me, it's just it is a partnered. Okay. So if you specify a certain null, also please specify your alternative. So we can know our relationships. Okay. Number 3, find the critical values. Like I said, the critical values can be found what? Using the alpha, the level of significance, the DF, if you are going to use F-test and T-test, and also by using the different tables. Okay? Number 4 is to find the test statistic or the test value. So like I said, in terms of test statistic, it is the one that we solve using the given formula. Okay, again. Sige. So the critical value can be found using the table, okay, using the DF, using the level of significance. In terms of test statistics, we can find a certain value, okay, by using the given formula, even if it is Z-test, T-test, or F-test. Number 5 is find the p-value. So this finding the p-value, okay, is only applicable, okay, with our Z test. Okay? Again, the p-value approach is only available on our z-test. Okay, so it's not important to find the p-value, but if you are going to have a z-test, you should find the p-value. Okay? Number 6, make the decision to reject or not to reject the hypothesis. So later on, we will discuss or review what are the what are the steps on how we can reject or not to reject a certain hypothesis. And number 7, not so important, summarize the results. Okay? So here we have three types of hypothesis testing. Okay? So we have two-tailed test. So we have right-tailed test and we have the left-tailed test. Okay? Always remember, if you are going to do a certain two-tailed test, the thing that you need to remember is what? The symbols. So in terms of two-tailed test, the symbols of the following hypothesis are the following, or the following hypothesis is we have the not equal and equal. So if you have symbols like not equal and equal to, automatic, you need to do what? A certain two-tailed test. Okay, next. Okay, so like I said last time, if your parameter is greater than your value given, okay, greater than, automatic, you will use a certain right-tailed test. Okay? So therefore, if this is your alternative hypothesis, okay, your null hypothesis will be the complement or the opposite. So if this is greater, if it is greater than, this will be less than or equal. Because like I said, in terms of null hypothesis, we are dealing with equality. Okay? Next is we have the left-tailed test. Okay? So in terms of right-tailed test, if the alternative hypothesis states that the parameter is greater than the value, in terms of left-tailed test, the parameter is less than the value. So they are just opposite to each other. Okay? So if the parameter here, for example, the mean, is less than our k, so for alternative, therefore in our null hypothesis, our parameter, okay, is greater than or equal to k. Again, we have this equality symbol because it is a null hypothesis. Okay? Okay. So decision rule based on the rejection region. Okay. So whether you will use the z-test, t-test, or any test that is available, okay, the one thing that you need to remember is if the test statistic, okay, so number 1, so if the test statistic or the computed using the formula, okay, is in the rejection region, then we can reject the null hypothesis. On the other hand, if the test statistic is not in the rejection region, then we are fail to reject the null hypothesis. So we have these different bell curves present here in the bottom part of our presentation. So we have the left-tailed test, we have the right-tailed test, and we have the two-tailed test. Always remember, okay, for example, this is your F critical, okay, and the F test is found here. Therefore, we can say that we can reject the null hypothesis because the value of your test statistics F is in the critical region. On the other hand, for example, we have the test critical here or T critical here, and our T test statistic, okay, is found here. Okay, the test statistic here is not in the critical region. Okay, therefore, okay, we are fail to reject the null hypothesis. So, okay, so if we observe the illustrations, okay, so the critical regions are the one that are what highlighted. So in this case, this is color gray. Sometimes you can just use a highlight like this in the graph. Okay, so always remember, guys, your class, okay, if the standardized test statistic, okay, the standardized test statistic is the one that we solve using the formula, is in the critical region or critical rejection region, therefore, we can reject the null hypothesis. On the other hand, if the test statistic is not in the critical rejection region, therefore, we are fail to reject the null hypothesis. That's so simple. Okay, please remember that. It's so important in order for you to decide whether to reject or fail to reject a certain H sub 0 or null hypothesis. Okay? So, in terms of standardized test statistics, so if you have n is greater than or equal to 30, automatic you will use the z-test. Okay? So, if your n is less than 30, automatic you will use the t-test. That is what? The basis. Okay? Again, if your n is greater than or equal to 30, use the z-test. If your n is less than 30, use the t-test. Okay. So in terms of p-value, like I said, if you have a certain z-test, okay, you can get the certain p-value. Okay. So in terms of p-value, okay, so always remember that if your p-value is less than or equal to level of significance alpha, therefore you can reject the null hypothesis. On the other hand, if your p or p-value is greater than your level of significance alpha, then you are fail to reject your null hypothesis. Okay, so please remember the relationship. Again, if your p-value is less than or equal to alpha, then you can reject the null hypothesis. If your p-value is greater than your alpha, then you are failed to reject the null hypothesis. Okay? So again, you can use the following test statistic formulas for the z and for the t-test. Okay? So in terms of t-test, so you need to find the df or the degrees of freedom. Okay? So we're in the basic one. We have n minus 1. Okay? So let's have an example here. A company believes that the average time its customer service representatives spend on a call has decreased from 8 minutes. So a large sample of 150 calls is analyzed, and the sample mean call time is found to be 7.5 minutes. With a sample standard deviation of 2 minutes at a significance level of 0.01, does the data provide sufficient evidence to support the company's belief? So what is the claim here? So like I said, the claim can be found in the first part or the last part of the problem. So in this case, the claim can be found in the first part of the problem. Okay, so let's read again. Spend on a call has decreased. Okay, so if you have the word decrease, okay, automatic, it is less than. Therefore, our mu is less than 8. So this is our what? Alternative hypothesis. And our mu for the null hypothesis, we have the opposite. So we have greater than or equal to 8. So this is our null hypothesis. Okay. So again, so our null hypothesis of mean is greater than or equal to 8, and our alternative hypothesis is we have the mu is greater than 8. Okay, so we have a level of significance alpha 0.01, and our DF is 149. Okay, so next one is we need to find the T critical. So we have here the parameter is less than 8, or the parameter less than the value. Therefore, we will have a left-tailed test. Okay? So in order for us to find the critical, we will seek what? The table. Okay? So if you use the table, t-test, you will get the value of T critical is equal to negative 2.35. Okay? So just use the T distribution table using the what? One-tail t-test. Okay? For the test statistic, so we need to solve this by using the formula. So we have here sample mean minus population mean all over, what's our 2? Standard deviation over square root of n. Okay? So we have 7.5 minus 8 all over 2 over square root of 150. Therefore, we have the value of test statistic equal to negative 3.06. So we have a left tail. Therefore, we are dealing with negative values. Okay. So, for example, this is our critical region. Okay. So, our T critical is placed here is equal to, we have negative 2.35. So, this is 0 in the middle. Okay. So, we have negative value. So, we will use the left tail. Okay. And let's assume the t-test is here. Okay. So, the value of our t-test is equal to negative 3.06. Okay. So, the value of our t-test or the computed test statistic is in the critical region. Therefore, we can reject the null hypothesis because the t-test, okay, is less than t critical. So, negative 3.06 is less than 2.35. Therefore, we can reject the null hypothesis. And the very basic explanation, so why we rejected the null hypothesis is because the t-test is in the critical region, or the value of our t-test is in the critical region. Okay? Next example. A quality control manager at a manufacturing plant believes that 8% of the products coming off the assembly line are defective. In a recent inspection, so a random sample of 250 products was taken and 28 were found to be defective. At significance level of alpha is equal to 0.10, is there sufficient evidence to reject the manager's claim? Okay. So what is the claim here? So a quality control manager at a manufacturing plant believes that 8% of the products coming off the assembly line are defective. So this is the claim. Okay? So it means, okay, our mu, okay, is equal to, so we are dealing here with proportion, okay? Because we have this percentage, okay? So like I said last time, so if you have percentage in your problem, automatic, this is a proportion, okay? So the claim here is there a sufficient evidence to reject? Therefore, if there's a word reject, it symbolizes not equal to, okay? So our H1 is we have proportion is not equal to 8%, or this can be converted as 0.08. Okay, so for our null hypothesis, the opposite, so we have proportion is equal to 0.08. Okay, so let's start this problem. So let's start by determining our hypothesis. So we have the null hypothesis and we have the alternative hypothesis here. Next one is we need to find a certain critical value. So in terms of proportion, so we will use the standardized Z test. Okay? So we have 0.10 here. So for our Z critical, so our Z critical, so we have two-tailed here because we have not equal and equal to. Okay? So we have level of significance of alpha is equal to 0.10. So in order for us to get the value of our Z critical, we need to divide this by 2. Okay? So our alpha will become 0.05. And by looking at the table of Z positive, okay? So in terms of two-tailed test, again, you will look at the value, okay, in the negative table. Okay, so let's look at the negative table. So where's the table here? Okay, so let's look at the negative table of the Z value. Okay, so let's look at the value that is close to 0.05, okay, but less than. Okay, so let's verify if 1.645 is correct. Okay, so 1.645. Okay, so it's correct because we have this 1.60 here, 64 or 65. So let's just use 1.65. Okay? So we have 1.6 and 1, 2, 3, 4, 5. Okay? So 0 here. We have 0, 1, 2, 3, 4, 5. Okay? So it's between the two. So we have 1.645 here. Okay? So let's go back. Okay? So like I said, we can find a certain z-critical value of a two-tailed test, okay, by using the negative what? Negative z-table, okay, and you will use the half of the given level of significance or alpha, okay, and you will look at the value with z-score that is close to 0.05 but less than. So we have positive, negative 1.645 because like I said, in terms of two-tailed test, we have two sides. We have the positive and the negative. Positive for the right-tailed and negative for the left-tailed. Okay. Next one is we will solve this problem using we will solve the test statistic using this formula. So we have z is equal to p hat minus p all over square root of pq over n. So in order for us to find the p hat, so we have this formula x over n. Okay, so our x is 28. Okay, because based on the problem, we have 28 were found to be defective out of 250. And our big letter n is equal to, we have, what's our sample? We have 250. So, we use that, what? Ratio. Okay? So, we have p hat. So, this is the value of p hat minus proportion. So, we have 0.08 or 8%. Okay? All over square root of 28. Okay? And always remember, q is equal to 1 minus p. Okay? So, we have 28 over 250 multiplied by 1 minus 28 over 250 all over 250 is we have 1.865. Okay? So, this is the value of our test statistic. Okay? So, we have a positive value. So, we will draw a certain critical region in the right side. Okay? Okay? So, for example, this is our, so this is Z critical. Okay? So, our Z critical is equal to, we have 1.645. So, let's assume the z-test is here. So, our z-test is equal to 1.865. Okay. So, after our calculations and determination, okay, or determining a certain value, okay, we can conclude that the value of our test statistic is in the critical region. Therefore, we can reject the null hypothesis. The z-test value is greater than the z-critical value. So, we have 1.865 is greater than 1.645. Therefore, we can reject the null hypothesis. And again, we can reject the null hypothesis because the value of your test statistic is in the critical region. Okay? Next example. A local balloon company claims that the variance for the first time its helium balloons will stay afloat is 5 hours squared. A disgruntled customer wants to test this claim. So she randomly selects 23 customers and finds that the variance of the sample is 4.5 r squared. At alpha is equal to 0.05, does she have enough evidence to reject the company claim? Okay? So, the claim here is to reject. Therefore, we have this word reject. We are dealing with not equal to. So, the first step is we need to determine the hypothesis. So, we have the variance is equal to 5 for the null hypothesis, and the variance is not equal to 5 for our null hypothesis. So, in order for us to find the critical value, so we have here a two-tailed test. Okay? Therefore, we will divide our alpha by 2. So we have 0.025 as our alpha, and our DF is 22. Because we have N is equal to 20, our N is equal to 23. So DF, N minus 1, okay? 23 minus 1, therefore we have DF is equal to 22. So in order for us to find the lower critical value and the upper critical value, you need to use what? The chi-square table. So in order for us to find the value, so you will look at the 0.025, okay, and the x 0.975. Okay, and you will find the values in terms of DF22. So you have 10.982 and you have 36.781. Okay. So let's calculate the test statistics. So in order for us to calculate the test statistics, so we have this formula. Okay. So we have n minus 1 multiplied by our sample variance all over population variance. So substitute the values. So we have quantity 23 minus 1 multiplied by 4.5 over 5 is we have 19.8. Okay. Please listen carefully. Okay. Always remember, if the value, okay, if the value of your test statistic, okay, is within the value of your lower critical value and the value of your upper critical value, then you are failed to reject. Okay, on the other hand, if the value, okay, of your test statistic, okay, is not between a certain value of your critical values, therefore, you can reject the null hypothesis. So in this case, the value of our test statistic is within the lower and the upper critical value. So our value of our test statistic is in the middle of the two. Therefore, like I said earlier, we are failed to reject a certain null hypothesis because the value of our test statistic is between or within the values of our lower and upper critical value. Okay, I hope this is clear for everyone. Okay, next we will discuss the module 3.2. So in this module, we will discuss the hypothesis testing of two parameters. Okay, so in terms of hypothesis testing of two parameters, so we have again three types of tailed here. So we have two tails here. So we have right-tailed here and we have the left-tailed here. So again, in terms of two-tailed test, so we have the symbols not equal to and equal to. So in terms of right-tailed test, again, in terms of alternative hypothesis, okay, the symbol is greater than. And for the left-tailed test, for the alternative hypothesis, the symbol is less than. And for the null hypothesis, it is just what? The complement symbol. So if this is greater than, this will be less than or equal. If this is less than, this will be greater than or equal. And again, there are equal signs because in terms of null hypothesis, we are dealing with equality. Okay? So testing the difference between two means. So if our problem, okay, so if the sample problem, so if the n or the sample size is greater or equal to 30, again, you will use the z-test. So in terms of test statistics, so we have this formula, quantity x bar 1 minus x bar sub 2 minus quantity mu1 minus mu2 all over square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. And this one, this part of our z-test statistic formula is called as the standardized error. Okay? So, on the other hand, if your n is less than 30, this is the formula that you need to use. So, you will use the t-test statistic formula. Okay? So, this standardized error, okay, like I said, can vary, okay, or it depends on your problem. So we have here two possible what? Conditions. So the first condition, so if the population variances are not equal, okay, and the second condition is if the population variances are equal. So let's discuss first what is the standardized error that we need to use if our population variances are not equal. So the standardized error that you need to use here is we have square root of s sub 1 squared all over n sub 1 plus s sub 2 squared all over n sub 2. Okay, therefore, this is our standardized error. And our s sub 1 squared is your sample variance. In order for you to find the df, okay, you will use this formula given. Okay, on the other hand, if your population variances are equal, okay, the standardized error that you need to use in the t-test statistic formula is this one. So we have SP or pooled variance, pooled standard deviation multiplied by 1 over n sub 1 plus 1 over n sub 2, wherein your SP or your pooled standard deviation is equal to square root of n sub 1 minus 1 multiplied by s sub 1 squared plus quantity n sub 2 minus 1 s sub 2 squared all over n1 plus n2 minus 2. So you need to solve here the SP, and after you solve the SP, just plug in the values here in the formula. Or you can just derive the formula, just enter the value of your SP in terms of equation to this given equation here. So it's up to you what process you will use. And always remember, in terms of t-test of a certain population variances are equal of two parameter hypothesis testing, okay, your DF is equal to n sub 1 plus n sub 2 minus 2. Okay? So let's have an example here. So example. So a company is evaluating two different advertising campaigns. So we have campaign X and campaign Y to see if campaign X leads to a significantly lower average number of website clicks compared to campaign Y. A sample of 200 customers exposed to campaign X resulted in an average of 15 website clicks with a standard deviation of 4 clicks. On the other hand, a sample of 250 customers exposed to campaign Y resulted in an average of 17 website clicks with a standard deviation of 5 clicks. Using a significance level of alpha is equal to 0.01, okay, test the hypothesis that the mean number of website clicks for campaign X is significantly lower than the mean of website clicks for campaign. So in this case, what is our hypothesis? Our alternative hypothesis here is we have mu1 is greater than mu2, and our null hypothesis here is we have mu1 is, our alternative hypothesis here is we have mu1 is less than mu2, and our null hypothesis here is we have mu1 is greater than or equal to mu2. Okay, so because in the problem, okay, so based on the problem here, the claim, so the test the hypothesis that the mean number of website clicks for campaign X is significantly lower than. Therefore, the mu1 is less than the mu2. Therefore, if our mu1 or parameter is less than parameter, we will have a left-tailed test. Okay? So, we will do a certain test statistic. Okay? So, we will perform a certain z-test. Okay? So, in order for us to find the critical value, so if we have alpha is 0.01, so we need to find a certain value in the negative z table that is closest to 0.01 but less than. So let's see or prove that it is equal to negative 2.33. So let me just open a table. Okay. So let's look at the negative z table. and we need to find a certain value that is close to negative, 0.01. So we have here 0.0990. So it is negative 2.33 and 0.3. Therefore, it is equal to negative 2.33. So we are correct. Okay. So we have the z critical value of negative 2.33. So let's solve for the test statistics. So we will use this formula. So just substitute the values here. So this is 0 because we don't have any given population mean. Okay. So just substitute the values and you will get the value of negative 4.71. So let's draw a certain critical region. Okay. So our z critical here is equal to negative 2.33. So let's just assume that the value of our z-test is here. So we have negative 4.71. Okay. The value of our z-test statistic is in the critical region. Therefore, we reject the null hypothesis. So our z-test is greater than z-critical. So we have negative 4.71. Okay. Let me just correct this. So let me just correct this. So the z-test is less than. Less than. So this is less than. Okay. Typographical error only. So our z-test is less than the z-critical. So we have 4.71 is less than negative 2.33. Therefore, we can reject the null hypothesis. Like I said, the negative value is larger if it is closer to 0. Therefore, the z-test is less than because the value is much farther from 0. Okay. Example number 2 for this topic. A researcher wants to investigate if a new fertilizer, so fertilizer A, results in a significantly lower average plant height compared to a standard fertilizer B. A sample of 10 plants grown with fertilizer A resulted in the following heights. So we have 18, 20, 15, 17, 19, 16, 21, 14, 18, 17. On the other hand, a sample of 8 plants grown with fertilizer B resulted in the following heights in centimeters. So we have 22, 25, 20, 23, 21, 24, 26, and 22. Assuming the population variances are equal. Okay, so let's take note this word or phrase are equal. And using a significance level of alpha is equal to 0.05, test the hypothesis that fertilizer A leads to a significantly lower average plant height than fertilizer B. Therefore, our mu here, so our mu1 is less than mu2. So this is our alternative hypothesis. Okay, so our alternative hypothesis is we have mu1 is less than mu2, so our null hypothesis is the complement. Therefore, we have mu1 is greater than or equal to mu2. So we have n1 is equal to 10, n2 is 8, x bar 1 or our mean 1 is 17.5, mean 2 is 22.875. So we have s sub 1. So this is our standard deviation 2.173 and our standard deviation 2.031. So sir, how can we solve a certain mean and standard deviation of set of data by using only our calculator? Okay, so let's have a calculator techniques 101 about mean and standard deviation. Okay, let me just open my calculator. Okay, so let's skip this. Okay, so let me just open the calculator. Okay, so please watch carefully. So step number 1 again is we need to change our mode to stat. Okay, and please select number 1 or 1 dash var. Okay, select number 1 and let's input all the values of our first is we have the fertilizer A. Okay, so let's input all the values here in the calculator. So we have 18, we have 20, we have 15, we have 17, we have 19, we have 16. Okay, is there, okay, 16, next is 21, 14, 18, and 17. Okay, so in order for us to find the mean and the standard deviation, okay, so just press or click AC, go to Shift 1, okay, go to number 4 or var, okay, so N is the sample size, number 2 is the mean, number 3 is the population standard deviation, and number 4 is the sample standard deviation. So we need to find the sample standard deviation, so just click 4. Therefore, we have 2.173. So this is our standard deviation. And let's find the mean. So go to Shift 1. Okay. Go to number 4. And just click number 2 or select number 2 for the mean. So the mean is 17.5. Next, let's find the mean and the standard deviation of our fertilizer B. Okay. So go to mode. Okay. Stat. Number 1 per 1 dash var, and also what? Insert all the values. Okay, so what are the values here? So we have 22, 25, 20, 23, 21, 24, 26, and 22. Okay, again, just click or press AC, go to Shift, number 1, okay, go to number 4 for the var. First, we need to find the mean, so select number 2. Okay, so we have the mean of 22.875. Next, we need to find the sample standard deviation. Go to Shift, number 1, okay, number 4 for the var, and number 4 for the sample standard deviation. So just click enter. So we have 2.03. So that's how easy, okay, to find a certain mean and a standard sample deviation using the calculator. So we have this data available right now. Okay. So for the critical value, so we have alpha is equal to 0.05. So our DF, so in terms of here, so we have left tail test because, again, our parameter is less than our parameter. Okay. So we have this DF is equal to 10 plus 8 minus 2. Okay. So we are using this formula. So in terms of this formula, okay, our DF, again, so if our variances are equal, so DF is n sub 1 plus n sub 2 minus 2. So we have 10 plus 8 minus 2, we have 16. Okay. So our alpha is 0.05. So let's look at the T critical table or the T distribution table to prove this one. Okay. So let's go to T table. So one-tailed test. Okay. So our DF is 16. So we have what's our, so 0.05. So for one-tailed test, and DF is 16. So we have 0.05. DF is 16. Therefore, we have 1.746. Okay, so we have, so this is a left tail test. Therefore, it is what? Negative. So we have negative 1.746. So the next step is we need to find the test statistic. Okay, so first you need to find the pooled standard deviation. So by using this formula. Okay, and after you find, okay, after you found out the pooled standard deviation, just substitute the values here. So this is 0 again because we don't have any what? We don't have any population mean. Okay? So if we simplify here, so we have negative 5.365. Okay, so let's draw the critical region. So for example, our T critical is equal to negative, okay, 1.746, and let's assume that our T test statistic is equal to, we have negative 5.365. Therefore, the test statistic is in the critical region. Therefore, we can reject the null hypothesis. Okay. So our t-test is less than t-critical. So negative 5.365 is less than negative 1.74. Therefore, again, we can reject the null hypothesis. And again, the t-test statistic is in the critical region. Therefore, we can reject the null hypothesis. Okay? Next example. An airline company wants to compare the fuel efficiency, so in miles per gallon, of two different aircraft models, Model A and Model B. To do this, they randomly select sample 8 aircraft from Model A and 7 aircraft from Model B. So our N1 is 8 and our N2 is 7. So the sample data collected is as follows. So we have this mean is 22.5 for Model A. Our standard deviation is 2.8. Okay, so like I said, sample size is 8. Model B, our mean is 25.3 and standard deviation is 3.2. And the sample size is 7. Okay, so the givens here is the sample mean and the sample standard deviation. So assume that the population variances, okay, so let's look here. So the population variances are not equal, okay? Using a significance level of alpha is equal to 0.05, test the hypothesis that there is a difference in the average test scores between the two groups. So we will use the formula in terms of variances are not equal. Okay? So the claim here is we have the word difference. Okay? Therefore, we are going to do a certain what? Symbol not equal to. Okay? So our alternative hypothesis here is we have mu1 is not equal to mu2. Okay? So we're correct. So in this case, we are doing a certain two-tailed test. Okay. So first, let's solve. So let's solve for the what? DF. So in order for us to solve this DF, just use this given formula. Substitute the values here. So our DF is 12. So let's look at the table. So we are going to do a certain two-tailed test. Okay. So let's look at the table. So our DF is 12. And our alpha is 0.05. Two-tailed, 0.05, DF is 12. So we have 1.782. Oh, wait. DF is 12. Two-tailed, two-tailed. So we have two-tailed. Okay. So two-tailed, 0.05. DF is 12, so we have 2.179. Okay, so this is 2.179. Okay, so we're correct. Okay, so our T critical value is equal to, so this is two-tailed test. Therefore, we have positive, negative 2.179. For the test statistic, just use the given formula. So again, this is 0 because we don't have any population mean and population mean. Okay, so in order for us to find the decision, so let's just compute the t-test statistics. So we have this negative 1.791. Okay, let's draw a certain critical region. So our t critical is equal to negative 2.179 because we are going to do a certain so we have negative here, so therefore we will use the negative value of our t critical. Okay, so let's assume that the value of our t-test statistic is here, so it is equal to negative 1.791. Okay, so that the value of our test statistic is not in the critical region, therefore we are failed to reject a certain null hypothesis because the value of our t-test is greater than the value of our t-critical. So we have negative 1.791 is greater than negative 2.179. Okay, therefore we are failed to reject the null hypothesis. And again, we are failed to reject the null hypothesis because the value of our test statistic is not in the critical region. Okay. So for testing the difference between proportions, so in terms of proportions test, we will use the standardized z-test statistic or z-test. Okay? So we have this formula: z is equal to quantity p hat sub 1 minus p hat sub 2 minus p sub 1 minus p sub 2 all over square root of p bar q bar multiplied by 1 over n sub 1 plus 1 over n sub 2. So our p bar is equal to x sub 1 plus x sub 2, or the number of successes in a certain problem, all over n1 plus n2, or our sample size. In our q bar, like I said, always remember that q is equal to 1 minus p. Okay? So let's have an example here. An airline company wants to determine whether the proportion of on-time flight is higher for airline A compared to airline B. Okay. So in airline A, for 100 flights were sampled, so this is our N, and 320 were on time. So this is our number of successes. On the other hand, in airline B, 500 flights, this is our N, and 390 were on time. So this is our number of successes. Okay? So at alpha, at a significance alpha 0.05, test the claim that the proportion of on-time flights for airline A is greater than the proportion for airline B. So our alternative hypothesis here, or the claim, is we have the proportion is greater than, or proportion 1 is greater than proportion 2. Okay? So we're correct. So if we have greater than sign here, therefore we have a right-tailed test. Okay. So we have p sub hat 1, okay, is equal to 320 over 400. So we have here 0.8. So we need to find the proportion. So we have p sub hat 2, 320 over 500. So we have 0.78. So next step is we need to find the p bar. So we have x1 plus x2 over n1 plus n2. So we have 0.7889. And next we need to find the q bar. So we have 1 minus p. Therefore 1 minus 0.7889. So we have 0.2111. So next step is we need to find the critical value of our alpha. So the first step is you need what? To subtract our level of significance from 1. So 1 minus 0.05. So we have 95. We have 0.95. And you will look at the positive z table, okay? A value that is closest to 0.95 but less than. So if you look at the table, okay, so let's find a certain value closest to 0.95. So let's use the positive z table here. So where's the positive z table? Okay. So what's the value closest to 0.95 but less than? So we have 0.9495. So we have 1.64. Okay, so let's go back to the problem. So we have 1.64 here, or 1.65 whatsoever. So this is our value of our z critical. Okay, next one is we need to solve for the test statistics. So we have this formula that I introduced earlier. So just substitute the value. So this is 0 because we don't have any population proportion. Okay, so let's just substitute the values and you will get the answer 0.731. So let's write a certain critical region. Okay, so our T critical is equal to 1.64 or 645. So let's assume that our T test statistic is here. So this is equal to 0.7731. Okay, so the value, this is Z, Z critical Z test. Okay, so the value of our Z test statistic is not in the critical region. Therefore, we are failed to reject the null hypothesis. Okay, so the value of our test statistic is less than the T critical. So 0.731 is less than 1.645. Therefore, we are failed to reject the null hypothesis. And again, the value of your test statistic is not in the critical region. Therefore, we are failed to reject a certain null hypothesis. Okay? So testing the difference between two variances. So we have this formula for the F-test statistic. Variance squared, variance 1 over variance 2. So where the larger of the two variances is placed in the numerator regardless of the subscript. So the F-test has two terms of degrees of freedom. So we have the DFN and we have the DFD. Wherein the DFN, so the DFN is the sample size from which the larger variance was obtained. Okay, so this is for the larger n, and this is for the smaller n. Okay, so let's try this. The standard deviation of the average waiting time to see a doctor for non-life threatening problems in the emergency room at an urban hospital is 32%. At a second hospital, the standard deviation is 28 minutes. The sample of 16 patients was used in the first case and the 18 in the second case. Is there enough evidence to conclude that the 0.1 significance level, that the standard deviation of the waiting time in the first hospital is greater than the standard deviation of the waiting times in the second hospital? Therefore, the claim here, okay, so we have the word greater than, so we have here standard deviation 1 is greater than standard deviation 2. Okay? So we have this givens. So this can be also represented as S. Okay, guys? So this can be represented also as S. Okay, so we are done with the hypothesis. So for the critical value, let's solve the critical value. Okay, again. So our DFN, so our DFN here is 15 and our DFD is 17. Okay? So correction. Okay. So our DFN is for the smaller n and our DFD is for the bigger n. So in this case, the smaller n here is 16 for the N1 and the bigger n is 18. Therefore, this is our DFD and this is used for the DFD and this is used for the DFN. So our DFN 16 minus 1, because like I said, DF is n minus 1. So 16 minus 1, DFN is 15, DFD is 17. So for the F critical, so in order for us to find the F critical, we will use the what? F distribution table. So this is a right-tailed test because we have the symbol greater than. So let's use the F distribution table. Okay. Okay. So our alpha is what? 0.01. So let's look at 0.01. Okay. Our DFN, our DFN is 15 and 17 for the DFD. So DFN is 15. Okay. Okay. DFN is 15 and our DFD is 17. So what is the value? So we have 3.31. So it is a right-tailed test. Therefore, it is what? Positive. So we have F critical. Okay, so F critical is equal to 3.31. So in order for us to solve for the test statistic, all you need to do is to get the squared of your S1 or standard deviation 1 over the squared of your standard deviation 2. So we have 1.30. Okay. So let's draw a certain critical region. So our F critical or FC, okay, is we have 3.31. And let's just assume that the value of our F test statistic is here. So we have 1.30. So the value of our F test statistic is not in the critical region. Therefore, we are failed to reject the null hypothesis. So our F test statistic is less than F critical. So 1.30 is less than 3.31. Again, we are failed to reject the null hypothesis. Okay, and again, and again, the F-test statistic is not in the critical region. Therefore, we are failed to reject a certain null hypothesis. Okay? Next, we will discuss the module 3.3 or the analysis of variance, or what we called as the ANOVA. Okay? So in terms of analysis of variance or ANOVA, like I said, our hypotheses are constant. Okay? So the hypothesis that we need to use in terms of ANOVA is we have here null hypothesis. So we have mean 1 is equal to mean 2 is equal to mean 3 is equal to mean sub k. So this k, like I said, it will depend on your given groups. Okay? So in terms of ANOVA, so we are going to test the difference between 3 or more groups or means. So therefore, this k will depend on how many groups present in your given problem. Okay? So in terms of our alternative hypothesis, so at least one mean is different from the others. So in order for us to find the DFN and the DFD, so in order for us to use the F distribution table, so DFN is equal to k minus 1. So where k is the number of groups in the problem, and our DFD is n minus k, so where n is the sum of the sample size of the group minus the number of groups. Okay? So example, so a state employee wishes to see if there is a significant difference in the number of employees at the interchanges of 3 state toll roads. So the data are shown at alpha is equal to 0.05. Can it be concluded that there is a significant difference in the average number of employees at each interchange? So we have this given data table. So we have n, 1, 2, 3, 4, 5, 6. So our small letter n is 6. And what is the total number of x or variables here? So if we have here 6 and we have 3 groups, okay, so our k is 3 because we have 3 groups, so 1, 2, 3. And our big letter n, or the total number of sample, okay, here is we have 6 times 3, so our big letter n is 18. Okay? So we need to solve for the mean and the variance of each. So by using the approach earlier. So you can use the approach earlier wherein you will use the calculator. So in that case, so if you want to solve for the variance, so please use the calculator in order for you to solve for the standard deviation, and you will just what? Square it. Okay? So let's have a demo. Okay, for example, so let me just open the calculator here. So for example, we need to solve for the mean and the variance of column number 1. Okay. So go to mode, stat, go to number 1, so 1 dash var. Okay. So just enter all the values. You have 7, 14, 32, 19. We have 10 and we have 11. Okay, so let's first find the mean. So click AC. So go shift number 1, go to var number 4, and click number 2 for the mean. So the mean is equal to 15.5. So next, we need to find the variance. So in order for us to find the variance, we will determine the standard deviation and we just square it. So go to shift number 1, go to var. Okay. Select number 4 for sample standard deviation. So we have 9.049. So let's just store it. So shift, store. So let's select A. Okay. And after we determine the certain standard deviation, so in order for us to find the variance, we just need to what? To square it. So we stored the function or the value in A. So we have A raised to 2. So we have 81.9. So just do the steps on our column number 2 and column number 3. Okay? So we have different values of our means and variance of different groups. So next one is we need to find the what? Grand mean. So in order for us to find the grand mean, all we need to do is to add all the values and divide it by our total number of variables. So we have here, like I said, our big letter N is 18. So in order for us to find the DFN, so DFN is equal to K minus 1. So 3 minus 1, we have 2. DFD N minus K, so we have 18 minus 3. Our DFD is 15. So in order for us to find the F-test statistic, so we need to find the ratio of MSB and MSW. So first, in order for us to find the MSB, so we have this SSB over DFN. And in order for us to find the MSW, all we need to do is to have the ratio of SSW over DFD. Okay? So in order for us to solve for the SSB, we have this formula, N, summation of x sub 1 minus x grand mean raised to 2. So all we need to do is what? Substitute the values. So our x sub 1 is the values of our mean. So we have 15.5, we have 4 and 5.83 minus the grand mean that we computed raised to 2. So we have SSB is equal to 4.22. So in order for us to find the MSB, just substitute the values for SSB over our DFN. So our DFN is 2. So our MSB is equal to 229.11. So next, we need to find the value of SSW. So the formula is summation of N sub 1 minus 1 over S sub I squared. Okay, so like I said, our N's are equal. So we have N is equal to 6. So all we need to do is what? 6 minus 1 multiplied by our computed variance plus 6 minus 1 computed variance 2 plus 6 minus 1 multiplied by computed variance number 3. So just add all the values or simplify. So our SSW is equal to 682.35. In order for us to find the MSW, just get the ratio of SSW over DFD. So we have 682.35. So our DFD is 15. So our MSW is equal to 45.49. So next step is we need to find the F-test statistic. So it is MSW over MSB over MSW. So we have 229.11 divided by 45.49. So our F-test statistic is equal to 5.04. Okay. So like I said, our hypothesis is constant. So we will use this constant hypothesis here. For the null, mu1 is equal to mu2 is equal to mu3 because we have 3 groups given. And our H1 or alternative hypothesis, at least one mu is different. So for our critical value, so we have 0.05 as our level of significance. Our DFN is 2 and our DFD is 15. So let's look at the F distribution table in order for us to find the F critical value. Okay. So F distribution table. So what is our alpha? So our alpha is 0.05. Okay, so let's look at 0.05. Okay. So our DFN is 2. And our DFD is what? 15. Okay. So we have here 0.05 I mean. So let's 0.05. Where's 0.05? Okay. So DFN is 2, DFD is 15. So we have 3.68. Is it right? Okay. So we have DFN is 2, DFD is 15. Therefore, we have 3.68. Okay. So our F critical value, okay, is equal to 3.68. And if we go back in our previous page, so our F test statistic is 5.04. So we have our positive. So let's look at the right. So we have here for this our F critical is equal to 3.68. And let's assume that the value of our F test is here. So F test is equal to 5.04. So the value of our F test statistic is in the critical region. Therefore, we can reject the null hypothesis. So our F test is greater than F critical. So 5.04 is greater than 3.68. Therefore, we reject the null hypothesis. And again, the value of our F test is in the critical region. Therefore, we can reject the null hypothesis. Okay? Another example, a company is testing three different marketing campaigns, A, B, and C, to see if they have different effects on website traffic. They randomly assign 15 days to each campaign, so 45 days total, and record the number of website visitors each day. Okay, so campaign A, so we have mean of 150, standard deviation 10. Campaign B, we have mean of 160, standard deviation 12. We have campaign C, means 155, and our standard deviation is 11. So our alpha is 0.05. Test the claim that there is no difference among the means. So here our case 3, because we have 3 groups, our small letter n is 15 because assigned 15 days each. And our big letter n, so the total is we have 45. We have 45. So let's start the problem. So the first one is we need to what? We need to determine the x grand mean. So in order for us to find the x grand mean, if we have given means and standard deviation, so we will use this formula. So x grand mean or x bar grand mean or mean grand or grand mean is equal to summation of x bar I multiplied by small letter n over big letter n. So just substitute the value. So x grand mean is equal to 155. So our DFN, so we have k minus 1, so we have 3 minus 1 is 2. N minus k is we have 45 minus 3, so we have 42. So our small letter n is 15. Okay. So we'll find the value of our F-test statistics. So again, we need to find the value of MSB over MSW. So in order for us to find the MSW and the MSB, first we need to find the value of our SSB and SSW. So just substitute the values here. So we have the means given minus the x grand mean that we computed squared. So SSB is 750. So in order for us to find the MSB, just get SSB over DFN. So our DFN is 2. So 750 over 2. Our MSB is 375. So next, we need to find the SSW. So we are given with the standard deviation. So we need to square it. Okay? Unlike the first problem, so it is already a variance, so don't need to square it. But in our case here, we are just given with the standard deviation. So we need to square it in the solution. Okay? Just simplify this solution. So we have SSW is equal to 5,110. And get the MSW, so SSW over DFD. So we have 5,110 over our DFD 42. So our MSW is 121.67. And for our F-test statistic, so we have MSB over MSW. So just write the values of each. So 375 all over 121.67. So our F-test statistic is equal to 3.08. Okay. So like I said, our hypothesis in terms of ANOVA is constant. So just write the hypothesis here. And for the critical value, we need to find a critical value. If our alpha is 0.05, our DFN is 2, and if our DFD is 42. So let's look at the F distribution table, okay, if the following DFNs are available. Okay. So our alpha is 0.05. Okay. So we have DFN. So our DFN is 2. So we have 2 here. Okay. And our DFD is 42. So there is no given DFN. Okay. So how can we solve a certain value if there is no given DFT? Okay. So we will use what? The interpolation. Okay. We will use the interpolation. So we have this formula, y is equal to y sub 1 plus x minus x sub 1 multiplied by y sub 2 minus y sub 1, okay, over x sub 2 minus x sub 1. So just substitute the values and we will get 3.22. But we can also use the calculator. Okay, so this time we will use the calculator in terms of interpolation. Okay, so go to mode. Go to stat, okay, go to here, number 2, a plus bx, so 2. So our x1 here is 40. So what is the paired value of 40? So we have here, in terms of the F2, So we have 3.23. Okay. Next, what is our x2? So our x2 is 60. So what is the paired value? So we have, what's the paired value? So if this is 3.23 for 40, so we have 3.15 for 60. So we have 3.15. Okay. Press enter. Click AC. And please enter the desired x. So we have 42. So we need to find the what? Value in terms of 42. So enter 42. Go to shift. Press 1. Go to number 5 for regression. And select number 5 for our y hat. Okay. And click enter or equal. So we have 3.22. So they are just the same as our interpolation in terms of manual calculation. So we have what? F critical is equal to 3.22. And our F test statistic is 3.08. So let's write a certain or draw a certain critical region. So our F critical is 3.22. So let's just assume that our F test statistic is here. So it is equal to 3.08. So our F test statistic is not in the critical region. Therefore, we are failed to reject the null hypothesis. Okay? So our F test is less than F critical. So 3.08 is less than 3.22. So we are failed to reject the null hypothesis. And again and again, the F test statistic is not in the critical region. Therefore, we are failed to reject the null hypothesis. Okay? Okay, for the last part of this review, so we will discuss module 3.4, all about correlation and regression. Okay, so in terms of correlation, so is used to measure the strength of the association between two variables. So, like I said, based on our graph or scatter plot, so the how close the variables to each other. So how strong the association is. On the other hand, regression is used to predict the value of a dependent variable based on the value of at least one independent variable. So in this case, we will use the regression line equation. Okay? So we have a simple linear regression equation provides an estimate. So we have y hat sub I is equal to b sub 0 plus b sub 1 x sub I. Or this can be represented also as y is equal to a plus b x. Or it is what? A slope-intercept form. So this can be represented as y is equal to mx plus b, or y is equal to a plus bx. Okay. So we have this formula in order for us to find the b sub 1 and the b sub o, or the b sub 0. So b sub 1 is equal to sxy over s double x, and b sub 0 is we have y bar or mean of y minus b sub 1 multiplied by x bar. So this is the formula, find the sxy. So but this can be derived as, xe summation of xy minus summation of x multiplied by summation of y all over n. Okay, so this is sxy. So for the s double x, it can be derived as summation of x squared minus summation of x quantity squared all over 2. Okay? So let's try this example. So a researcher is investing the relationship between the amount of fertilizer applied to tomato plants and the resulting yield of tomatoes. So they collected data from 7 different plants as shown below. So we have this table given. So formulate the linear regression equation that predicts tomato yield based on the amount of fertilizer applied. So the first step is we need to complete the table. So we need to get the value of xy, x squared, and y squared. So we will have the summation or the total values here because we need all the values given in order for us to solve for the equation. So first, we need to solve for the b sub 1. So b sub 1 is equal to sxy over s double x. So we need to solve first for the sxy and the s double x. So like I said, this is the derived formula of the two. So just substitute the value. So summation of exy here, summation. minus summation of x multiplied by summation of y over n. So our n is 7 because we have 1, 2, 3, 4, 5, 6, 7. So we have sxy is equal to 230. So s double x, summation of x squared. So summation of x squared, so 5,075 minus summation of x quantity squared over 7. So we have s double x equal to 700. So we need to find the value of b sub 1. Again, sxy over s double x. So we have 230 over 700. We have 0.33. Next one is we need to find the value of b sub 0. So we have this y bar minus b sub 1 x bar. As we all know, y bar is also mean. So e sub y, summation of y over n minus b sub 1 multiplied by summation of x over n. So we have summation of y. We have 70 over n is 7 minus the value of our what? B sub 1. So we have 0.329 or 0.33 as you should. Multiplied by summation of x. So we have 175 over n is 7. So we have is equal to 1.79. So let's arrange the what? The regression line equation. So as we all know, we have y hat sub I is equal to b sub o plus b sub 1 x sub I. So what's our b sub 0? Is we have 1.79 plus what's our b sub 1? 0.33 and just add x sub I. Okay, so that is our regression line in this problem. Okay? So measures of variation, always remember that SST is equal to SSR plus SSE. So SST is the total sum of squares, SSR is the regression sum of squares, and error sum of squares is our SSE. So SST is we have this formula, summation of y sub I minus y bar, quantity squared. SSI is we have summation of y hat sub I minus y bar raised to 2. SSE is we have summation of y sub I minus y hat sub I quantity squared. So y bar is the mean, y sub I is the values of y, and y sub hat I is dependent on your what? Regression line formula or regression line equation. Okay? So we have this formula for the R for the Pearson sample correlation. So we have this R is equal to xy all over square root of s double x multiplied by s double y. So if we derive this formula, we can come up with this alternative formula here for the Pearson correlation coefficient. Okay? So we have this interpretation of what your correlation coefficient stands for. So if you have 0.90, so just read this and please remember the interpretation. Okay? So coefficient for determination. So this is called as R squared. So the formula for coefficient of determination is we have SSR over SST. So R squared is equal to SSR over SST. So please note that our R squared is always greater than or equal to 0 but less than or equal to 1. It is a non-negative and it is also not greater than 1. Okay, so let's try this. A small business owner is investigating the relationship between the number of online advertisements they run per week and the number of customer inquiries they receive. So the following data was collected over 5 weeks. So calculate the following. So calculate the SST, the SSR, our R, and our R squared. So the first one is we need to solve for the SST. So just use the formula. So substitute the values of y. So we have 5, 7, 8, 11, 14. And our y bar is 9. Okay, so if we get the y bar is 9. Just get the mean here. So it is equal to 9. So our SST is equal to 50. So in order for us to solve for the SSR, you need the regression line equation. So how can we solve for the regression line equation using only our calculator? Okay, so let's try this. Okay, so open your calculator. Go to mode, stat, number 2. And just enter the values here. So we have 2, 3, 4, 5, 6 for the x. For the y, we have 5, we have 7, we have 8, we have 11, we have 14. Okay. So click AC. So shift number 1, go to 5 for regression. So let's find the value of our A or our B sub O, B sub 0. So we have 0.2. Excuse me. Okay. Next, we need to find the value of our B for our B sub 1. So we have shift 1. Okay, go to reg number 5 and select number 2. Okay. So we have 2.2. So we are correct. So we have a regression line equation. So we have y hat sub I is equal to 0.2 plus 22 point x sub I. So next, we need to find the SSR. So we have this formula here. So just get the summation. So we have this formula for the regression line. And all you need to do is to substitute all the values of x. So we have 2, 3, 4, 5, 6 here. And minus our y bar or our mean is 9. So raised to 2. And you will get the value of SSR is equal to 48.4. And next, we need to find the value of our r squared, your coefficient of determination. So we have this formula, SSR over SST. So just substitute the values that we computed earlier. So we have 48.4 all over 50. So we have 0.968. In order for us to find for the r, all you need to do is what? So you have already a given of r squared. Therefore, you can get the value of r by square root the value of your r squared. So just substitute the value of r squared here. So our r is equal to 0.984. So lastly, we have the population correlation coefficient hypothesis testing. So the hypotheses are constant here always. Okay. And in order for us to solve for our test statistics, so we have this t test statistic formula. T is equal to r multiplied by n minus 2 over 1 minus r squared. And our df that we need to use is df is equal to n minus 2. So let's have an example here. So let's use n is equal to 6. So again, the hypothesis testing or the hypotheses are constant. So just use this. So proportion correlation, population correlation. Alternative is not equal. So P or rho is equal to 0 in our terms of null hypothesis. So for the DF, so if our n is 6, so 6 minus 2 is we have 4. So alpha is 0.05. So our T critical, so if we have DF is 4 and we have two-tailed test. Okay, so let's look at the T distribution table. So T table, so we have 0.05 two-tailed test. And our DF is 4. So we have 2.776. Okay, so we're correct. So we have positive, negative, 2.776 for two-tailed because we have not equal and equal sign. So next one is we need to solve for the test statistics. So we have this formula here. Okay, so r is greater than, r is square root of n minus 2 over 1 minus r squared. So if we solve this, we have this answer here. Okay, so we have this 4.058. So let's draw a certain bell curve. So for example, this is our critical region. Our T critical is equal to 2.776. So positive. Okay. And our T test statistic is equal to 4.058. Therefore, our T test statistic is in the critical region. Therefore, we can reject the null hypothesis since our T test is greater than T critical. So we can reject the null hypothesis. So that's the end of our review for module number 3. I hope you learned something and good luck on your module 3 assessment, everyone. Have a good day and thank you for listening.